Assalamualaikum and hello everyone. Imagine living near the ocean, surrounded by water, but unable to drink it. Around the world, more than 2 billion people face water scarcity, making clean drinking water one of the most valuable resources on Earth. Today, our group will explore an important technology known as desalination, a process that converts seawater into safe drinking water. We will discuss how the process works, the problems and issues raised from the process in the context of mass and energy balances, and also Islamic perspective. We will also go through some suggestions for improving the processes. Desalination is the process of removing dissolved salts and impurities from seawater to produce fresh water suitable for drinking and domestic use. This technology is especially important in countries with limited freshwater resources, such as Saudi Arabia, the United Arab Emirates, and many coastal regions around the world. Now that we understand the importance of desalination, let's see how the process works through the reverse osmosis system and flowchart.
Next, we move to desalination process. Desalination process consists of 5 main stages. First, seawater intake. Second, pre-treatment filtration. Third, reverse osmosis. Fourth, post-treatment. And lastly, drinking water distribution. The first stage is seawater intake and screening. Seawater is collected from the ocean and pumped into the desalination plant. Before entering the treatment system, the water passes through a screen that removes large debris such as seaweed, plastic, shells, and other floating materials. This step helps protect the equipment from the damage and ensures smooth operation of the plant. The second stage is pre-treatment filtration. In this stage, the seawater is filtered to remove sand, slits, suspended solid, and other small particles. Chemicals may also be added to control microorganisms and prevent membrane fouling. This process improves water quality and protects the reverse osmosis membranes from clogging. The third stage is reverse osmosis, which is the main desalination process. High pressure is applied to force seawater through a semi-permeable membranes. The membranes allow only water molecules to pass through while blocking salt, minerals, and other contaminants. As a result, fresh water is produced while concentrated brine is separated as waste. After reverse osmosis, the fresh water undergoes post-treatment. Minerals such as calcium and magnesium may be added back to improve the taste and quality of the water. Disinfection is also carried out to ensure the water meets drinking water standard and is safe for human consumption. The final stage is drinking water distribution. The treated water is stored in tanks and distributed to homes, industry, and commercial facilities. The water produced is clean, safe, and suitable for daily use.
Water desalination process apply the mass balance principle. According to mass balance principle, the amount of input is equals to output. This means that the fresh water produced and the brine released from the process is equal to the salt water feed into the system. Take a look at this question. A reverse osmosis plant desalinates influent feed water which have the flow rate of 5 million liter per day containing 1500 mg per liter salts, and this plant produce 3 million liter per day of clean product water with only 75 mg per liter salt. So, to find the brine flow rate and concentration, we have to conduct the mass balance. First of all, we find the brine flow rate produced per day. The total amount of water entering must equal the total amount of water leaving. By substituting the flow rate of feed water and product into the equation, the calculated brine flow rate is only 2 million liter per day, which is much lower than the feed water. To find the brine concentration, the total mass of salt entering must equal to the total mass of salt leaving. By substituting the value from the information given into the equation, the calculated brine concentration is 3637.5 mg per liter, which is much higher than the feed water concentration. All salts from the feed water accumulated in the brine. Since the volume of brine is lower, which is only 2 million liter per day, the salt concentration in brine will become much higher. This high salinity brine can cause damage to the environment when being released. When brine is released into the sea, it will sink deep down to the sea floor due to its high density. This accumulation of brine on the sea floor causing osmotic stress to echinoderm species such as starfish. They have zero capacity to regulate internal salt that can lead to physiological failure and death. Brine release can also cause chemical contamination. Residual chemical treatment from the process such as biocides, antiscalants, and heavy metal can harm marine organisms.
From an Islamic perspective, environmental sustainability is emphasized in Surah Al-A'raf verse 56, where Allah says, "Do not cause corruption upon the earth after its reformation." This reminds us to manage desalination processes responsibly and minimize environmental impacts such as brine toxicity. To protect marine life from toxic brine, our first strategy is outfall engineering. We must place discharge pipeline in high wave dynamic marine zone to maximize natural mixing. By installing submarine diffusers angled upward at 30 to 45 degrees, we force the heavy brine into a parabolic plume, ensuring rapid dilution before it can settle on the seafloor. Next, we reduce brine density before discharge using pre-disposal dilution. This is done through seawater bypassing, blending raw seawater directly into the wasteline. Alternatively, we can practice co-disposal by mixing dense brine with low salinity urban wastewater or power plant cooling water to achieve safe and neutral buoyancy. In conclusion, while desalination is vital for overcoming freshwater scarcity, its toxic hypersaline brine is a major environmental threat. However, by using smart engineering like upward angled nozzle for rapid mixing, pre-diluting waste with regular water, and using rust-proof steel pipes, we can fix this problem. Ultimately, checking on sensitive sea animals prove that we can create clean drinking water while keeping our ocean perfectly safe.